we're getting ready to cut out some more stainless steel for our rudder. These two pieces of steel, the leading edge support and the trailing edge support or border or frame of the rudder, we've had a chance to look at this. We brought it up about 1/8 of an inch on the bottom, and we added a relief, bend curve relief, so that we will have clearance for our fastening on our zinc that's going down there and the zinc that's going to be going up here. So we have this scalloped out, and you'll see this in the new parts here when we get cutting them. Also, we decided the width is going to be 1.25 inches on our flat web that will be coming around here. We were able to take our drawing and actually break the line and get an end-to-end measurement. So we have 4 being cut out at this size, 4 being cut out for this length, 4 being cut out for this length here, so that we're doing both rudders. Once we get the new stainless steel ring, fins, and the flat bands all tacked together, then we're going to be able to take a straight edge, and we're going to be planning out for the bottom and the other top plate that will come up here along the top that will join directly to the skin. And then we'll start laying out and creating the skin with the rosette holes that will get welded on both sides. We want to build the rudder uniform on both sides. We're not going to just reach in and do some welding on here against the flat blade and then rosette weld on it. We're going to do the same. Everything is going to be uniform, and it's going to be a full weld seam all the way around the whole outside. Alright, let's get you a view on the table for our cutout, and we'll be adding in some on-the-screen viewing as well. I came up with a situation the other day where, I know I had really good electrode, and my nozzle definitely looked really good, and I was cutting up that Corvette piece there that I showed you guys on my Facebook. And the typical scenario, and it doesn't happen very often, but it dawned on me what the actual problem is. And also too, I like to wanted to go ahead and show you this. I'm going to go ahead and turn my machine back on. Because one of the things I like about my torch assembly is I can be at here and I don't have to walk around there. As soon as I break loose the outside housing on my torch here, it automatically shuts down, so I'm not getting shocked or anything. Now, even this electrode, I've been using it, and but it's still good, and this nozzle here also is still good. The problem, and of course you don't think about this part really wearing out because it's not your electrode and it's not your nozzle, but your starting cartridge does take a beating, and you do have arcs in the surface right around the front here. Really gets kind of beat up, and it has arcing going on here, and sometimes when this gets built up or freezes up, you stop being able to create an arc, and you'll search around and you know that you've got your air on and your machine's on and you know everything is working, but you're scratching your head and you're wondering why your torch is not running. Alright, and of course it happens so less frequent than you remember this kind of problem, so it's a mental thing. You got to remember, to check it out, because most of the time what will validate, sometimes you'll pop this apart in your early stages where this starts failing, starts getting built up here to where it's not really 100% all the time. You take your torch apart, you put it together, and it does about another dozen to 3 dozen pierces, and then it starts failing on you again. And then you end up having scratching your head and wondering why your machine's not running again. Okay, the starting cartridge do wear out. And that reminds me, I'm on my second spare here in the last, well, since I've had the PlasmaCAM. This will be my second change out, okay, so I get to put a new one in here. I just dawned on me the other day that's there, and I know I probably should go ahead and get a new O-ring and stuff like that. This, a lot of, I'm just kind of, this is used, and that one's used as well. Put that one in. Also too, inside here it gets some marking going on, and just kind of rubbing that kind of smooth now, because I'm going to have this new tip here, or new starting cartridge. Alright, so we got a new cartridge, and we're running an old electrode and old nozzle just to satisfy our own self here, that our problem is not always contact tip, not always electrode. And also too, I mean, it's happened for quite a while now, but Victor's and Thermodynamics are now one company. So, you know, to me that's merging of two good American companies there. Alright, I think we're ready to go. We've been making test circles right here in our corner, out of the way. This is a nested collection of parts that I put on here. And if you notice, I let it nest all the parts, and then I eliminated or removed all the, had tacos for dinner. I removed all the cut paths, and then I picked my own starting cut path on each one of these parts, and then I also picked out the order. So you'll see that I start the order near this edge, and I start my pierce so that the first cut comes where the material's thin, and the last part of the cut is against the full sheet. And I do that for each part. That way, when you're cutting, you're creating the heat and you're not cooling down your part. You keep the material located in the same spot until it drops it off. If you cut across your material and then come and you cut along this little skinny edge right here, you have no support for your part, and your part will take and twist and turn and things like that. So when it's important for you to, actually I think it's always important, if you want to cut something out in this shape, when you pull it from the table, you want it to be in that shape. So what I found, this method works the best to keep your parts true to size. Okay, I've highlighted the parts on the table that I'm going to cut, and basically I'm just looking real quick. There's the cut paths. So we're going to be zigzagging back and forth. We're going to be going from there to there. Okay, and actually, see that I unclicked those little circles so we don't have those in there. Alright, now there's the true cut paths, okay? So it's going to do this, one's going to switch to that one there, then it's going to do this big long one, and then we're going to slowly work our way up to the table. But each one of them is going to be an outside part, and it'll cut the outside before it cuts the inside of the plate. Alright, let me get some ventilation and we're going to hit go. And I'm cutting this at 60 amps. And by the time I came to where I had the hole to where I like the cut on the edge, and I'm going to take a look at it, a close peek at it after the first part here, so I can determine that I'm happy with the surface quality, and then we'll cut the rest of them out. Alright, let me start my draft here. comes off the table. All right, we'll let the rest of it run. Shut this down a little bit so that I can show you. See, we started here, and you can see how thin this material is right here. Coming around here, and even gets a little thin right in here again. Then when it gets to here and cutting across here, the material behind here is the strong back to hold your part true until it gets over here and drops the part off at the end. If you were to start it over here, like some of these pierce, when you put it in the nesting, some of the piercing actually starts your cut behind your part and comes out to the thin side. Watch out when you're doing that, because you can reorganize, and sometimes if you're going to do something, you can pre-pick the pierce pattern, and then you can tell it how to lay it out for you. All right? Or like in this batch here, I said, okay, I like that layout, but let's change the piercing and the cut pads. So I did on each one of these, okay? So here again, here's a part. And I don't know if all of you bring your guessometers or your dial calipers out here and make sure that your parts are within 4 or 5 thousandths from end to end. All right, we'll get back at it. I put this little shield up here just so it doesn't blow sparks on my mouse pad here. Yeah, I'm happy with cutting, so you just got to live with the sparks. All right, here we go. cut good all the way to the last bit there. I really glad I changed that start cartridge, and didn't mean to move you. But you can see how these pieces here do the warpage, and every piece drops off of there and is perfectly cut and shaped. And that's how you keep the trueness in your parts. You know, you don't care as the sheet diminishes and all this droppage that's all out here, all that stuff, you don't care what shape that takes after you're done with it. Alright, it's your parts. You really want to concentrate on how your parts are being cut out on the table. Now, 30 inches a minute was a little bit less than the recommended speed, but the quality of my cut and a nice, uniform, clean, straight part, that's what I'm looking for. So, alright, we're going to probably dress off this sheet right here, and then we're going to be dressing up some parts and start getting our wing shape going together a little bit. And the outside skin is actually going to be coming off at the end of this, and we have two other full-size 4x4 sheets that are going to be coming in here. We actually have a lineup for my machine here. It's the first time in a while for parts to be cut, and we got a couple different jobs going. So I'm out here tonight, and well, it's about 8:30 or so, and I'm just about done for the night, but I wanted to go ahead and get what I wanted off of this sheet so I get things moving here. Alright, we did a quick grind on these so we can pull these steel ones out and fit in our new stainless steel ones. Nothing's locked in yet, and we can grind and play a little bit. That was nice. I wanted this to come in a little bit closer to the bottom edge right here. That looks really good there. Alright, let's see if we can pull this outside one off of here. And that looks pretty good. And these are clearance right here for the added material that we're going to have in here to have threaded holes, and the drain plug that will be going in this outside skin there and here.